This is biased versus unbiased estimator, day 2. How many popsicle sticks are in the bag? Okay, let's go ahead and open up to how many popsicle sticks are in the bag. The first thing that we're tried to do is I gave everybody in the class a big bag of popsicle sticks, and I don't tell them how many are in the bag. So what I asked them to do is randomly grab 7 of them and write them down. Then we're gonna just kind of brainstorm some different methods of how to predict how many total sticks are in the bag. So one way we came up with was if we found the average, and my average was 32, and then I doubled it. And then we found the median, which was 36, and doubled it. Or maybe some people want to do the maximum of the sample or add the maximum plus the minimum just to get an idea of how many sticks were in the bag. So as a class, we investigated 2 methods, and this is the method that we are doing. And I told half of the class to do the maximum method and the other half of the class to do 2 times the median method. In the group, I had them collect 5 more samples, and I had them write down the collected and calculate the estimated total given the method that they've been assigned. And they wrote each estimate on the sticker, and they added it to the appropriate dot plot. What we did, instead of doing the sticker, we sent the data through the calculator, and we graphed it on our calculator and on the screen. This is the data that we ended up getting. On the left, this was the sampling distribution of the maximum, and this on the right is the sampling distribution of 2 times the median. So what each dot represents is the average of all of the is the maximum of the scores is this one. So for instance, one person got a maximum of 40, another person got a maximum of 49, 2 people got a maximum of 50, and so forth and so on. On the right-hand side, it's a sampling distribution that represents, each dot represents what one person got in their sample of 7 sticks. So method 2 seems to be better than method 1 because it's this one here. You can see the total, actually, the truth of population. We actually had 78 sticks, and you can see the entire method is an underestimate. This one seems much more accurate. Sometimes it's under, sometimes it's over, but it seems to be well balanced, and so we call it unbiased. Biased is when I'm constantly favoring one particular thing in one direction. That would be simply like, if someone says, oh, I like people that are over 6 feet tall, and anyone over 6 feet tall, I end up giving extra credit to, but anyone under 6 feet tall, I never give extra credit to. So in a consistent way, I would constantly be biased. Unbiased would be if I'm consistently giving them equally to all heights of people. Okay, you would improve if you use 10 popsicles rather than 5, because the bigger the sample is going to give you less variability. It's going to get closer to your actually truth of the population. This is the definition of biased estimator: consistently underestimating or consistently overestimating the true parameter. The true parameter meaning the population proportion, the population mean of whatever the average of the sample is. An unbiased estimator is the mean of the sampling distribution is equal to the true parameter. When you increase the sample size, it just decreases the variability of the sampling distribution. It makes it more precise by making it, so this is simple when I go ahead and I say the average, if I flip a coin, the proportion is 50%. But if I flip a coin 10 times, it would not be unheard of to get 7 out of 10 or 70% heads. But I know the population, I know that the coin is a 50-50 coin, but I got 70%. But if I flip it 100 times, it's going to get closer and closer and closer to actually 50%, because the more probability is really unreliable for short term, but it's reliable for long term. Okay, so this particular activity is really cool because it's actually a true thing that happened back in World War II. So basically, they wanted to see how many German tanks the Allies wanted to see how many German tanks they had so they could see how much they needed to prepare against their enemy and to help, save the war and win, so that we could, make sure that everything was safe in our country. So anyway, what happened is they had 7 tanks, and they sent the serial numbers back to the statisticians, and the statisticians used the 7 tanks and the 7 of the serial numbers to try to figure out how many tanks that they would have. And we did it kind of in a very similar way that the popsicle sticks did, what we did earlier. So these are the different methods, and which one, 1, 2, or 3, is unbiased. Well, 1 and 3 are unbiased because you can see the blue line represents the true population and the red line represents the population mean of the sample. Which one's the best? 3, sometimes people liked 3 because it seemed to be a smaller spread. I know I liked 1 because it seemed to be unbiased the most, because it seemed to be a nice even unimodal symmetric spread, and a similar way with too high and too low about equal amount. So the allies could get a more precise estimate by capturing more tanks, which would be great, increasing the sample size. And the more tanks that you have, the more accurate you're going to be able to know. All right, I hope this helped. Thank you very much.